Hey everybody, so I've got a small project that I'd like to do for this week's SNS. This is a small little shop made item that I have done in the past. This is actually many years ago I did this, and I was shown this by Sonny, and I've talked about Sonny in some of my past videos. I believe it was SNS 100. I might have mentioned Sonny. He was somebody that worked with us at the shop, and he was also a mentor as well as dad and granddad. I learned a lot of stuff from Sonny too, because he was a jam up machinist and he was very smart, very intelligent, and he's old school machinist, but he could do it all. So there was, I don't remember why, but it come up on a job where we were doing some power tapping. And so any of you guys that do this stuff all the time, or you know what I'm talking about here, taps, sometimes you want a power tap, and you can't always get your tap in a drill chuck, or you may not be in a position where you're using a drill chuck, and you may not have the proper collets to hold the shank of a tap, because taps are not a standard size. They're a little bit oddball size. I know that there's collets out there that have a range of size so that you can use for this, but we're going to disregard that for this video. And what we're going to focus on is if you're using like a Bridgeport mill and you're using a standard R8 collet. In my case, I'm going to use this 7/8 collet for the size that I'm going to shoot for. You can buy these. I know a lot of guys probably only have up to 3/4, but you can get a 7/8 collet. I believe this is the largest size you can get for R8. So anyway, a job had come up where we wanted to do some power tapping, and we were using the collet chuck, I believe, to drill the hole, and then we wanted to stick a tap in there and tap it, sort of like a production thing. So Sonny had told me what to do. He says, take a piece of stock, and this is something that I made, and you see I didn't do too good of a job as far as looks goes. Still got the saw cut ends. And take a piece of stock that'll fit a collet. In this case, we've got, I believe this one's going to be 1.25 right here. Yeah, so this is a piece of 1.25 cold rolled. And you take whatever tap size it is and you measure the shank, and basically you bore it so that it fits the shank nice. Got a nice fit on it. But you don't bore it quite all the way through, and on the back side here you actually mill a square that'll drive the shank there. So you slip your tap up in there, and then after you do the bores, the machining of the bore, and mill the square, you split it. And I believe we just used a hacksaw. That's what that looks like, is a hacksaw cut. This is another one right here for a 1/2" tap. This one being a 3/4. So that's one I made right there, and the tap's actually stuck in there. I can't pull it out of there. I have to put it in a vise. So anyway, this is a nice little project for any of you guys at home that would like to make some of these, and this is why I'm showing it. This is just a nice little project, and they're very helpful. You can make a range of sizes, and what we're going to do is I'm going to use some of this 1" stock right here. Now this is a little piece of stress proof, and stress proof is a free machining material, so it's nice to machine. It's soft, but it's got a lot of tensile strength to it. So there's just a drop. I threaded it on the end. I probably made this as a fixture or a jig or something, but we'll go ahead and face that off, and we'll do it on this end. But I'm going to turn it so that it'll fit up inside this collet, this 7/8 collet. And what we'll do is we'll only turn it so far, and we'll leave a shoulder on there so that whenever I decide to use this, you just stick it up in there into the collet up to the shoulder. So that's going to be our little project. We'll use the Victor lathe, we'll use the collet chuck over there, and there's not a whole lot to it. So let's go ahead and get started. Oh, before I forget, I don't know if I mentioned it now. I can't remember if I mentioned it, but we're going to build this for a 5/8 tap. So this is the tap right here. This is a 3 flute spiral spiral pointed tap. I can't even think of the name right now, but we got a 5/8 spiral fluted tap. So we're gonna machine it to fit this shank right here, this OD and this square, and then we'll fit it for this collet, and then maybe whenever we get through with it, we'll go ahead and test it out and tap a hole. All right, I'm gonna use this end right here because this side's already got that little bit of a hole that's too big, so there's not gonna be a whole lot of this left, so we're gonna cut that little stud off there, and we'll just use that in there. All right, so the length of our tool there, I think what I'm going to do is make it 1 3/8 of an inch long, and 3/4 of it is going to be on the shank here, and then we'll have 5/8 for the square. So I'll hang it out about 1 3/4 of an inch there. We'll go 1 7/8. How about that? All right, that should give us some room to work, because I want to do the machining. We're going to drill a hole smaller than what I need, and then we'll turn this end down for our 7/8, and then we'll part it off, and then we'll flip it around and stick it in a 7/8 collet and finish it out. And because I got it, let's use our 20N Jacobs chuck for the first time. This is actually right on the limit of, actually, yeah, I'm not going to be able to use it like I wanted to. I was thinking it was a little smaller than 3/8. That's the smallest drill it'll hold. Dang, man. No. Won't quite hold it. Okay, we'll have to save it for next time. So what I'm doing is I'm drilling a hole that's really close to the size of the square shank. That's measuring right about 360 thousandths, or 9 millimeter. It's just a little over 9 millimeter. So we'll use a 9 millimeter drill bit to drill our pilot hole down through there. I do want a hole down through it for whenever I'm parting it off. So we're just going to use this number 6 center drill here just to spot the end here, and then we're going to use this 9 millimeter drill bit. All right, we got our 0 set right here with the Hackmaster indicator, and we're going to turn it down 1/8 of an inch. Put a little witness mark there. So I'll just do it in halves. Be about 15/16 now, or about 9/37. About 9/36 right there. So we got about another 30, 31. I'm sorry, 60, 61. Let's see what we hit it on. Not a super tight tolerance right there. If you're off a couple thousandths, it's not gonna kill it. All right, so we got about 1 under right there. We're good to go. All right, we're gonna part it off. I'm just eyeballing 1 3/8, maybe a few thou over that, so we can just clean that face up and make it look pretty. We'll put our little catch rod in there, and we're ready to go. All right, we got the 7/8 collet in there, so we're gonna stick it in and tighten her up. And we'll go ahead and clean that face up, make it look pretty. Change the feed rate there. All right, now I need to find a drill bit. Probably go with something around a 7/16. Open the hole up, and then we'll bore it to size. So I'm actually going with an 11.5 millimeter drill bit right there. That's just because I got it, and it's real close to size. I already had the set opened up. So in inch size, this was about 478.5, 479. It's just over 12 millimeter. So if you're doing this the same size, you could use a 7/16 or a 29/64 drill bit. And I'm going to go in there. I'm going to watch my scale right here on the quill, and I want to try to go about 3/4 of an inch. All right, so this is the boring bar holder I'm going to use, and check this out. So this is one of the little boring bars that I picked up when I was in Moultrie a couple weeks ago. And this is a 3/8 shank, and I've got one of these bushings right here that this will go in. Perfect. I'm going to set it up just like this one right here. Now, y'all have seen me use this before. We used this recently on the gearbox shaft whenever we were counterboring it for the threads. I had a comment about that they couldn't believe that this thing didn't wiggle around and try to pivot, but this boring bar holder, you see it's got a V-notch in there, and we had it clamped down on the flat, so nice and rigid. Plus this is a solid carbide. Ultradex USA is the brand name on it right there. CCMT insert, I believe. So we can go in here with this one just like so. I don't think this is going to go down far enough. Wow. I didn't think that would work, but it did. So, I don't know if you're in the shot right there. So remember, you want to try to choke up on it as much as you can, and we're not going to be going in there very far, so I'm just going to, we'll try, all right, so that's about 1 1/4 inches. We're going to be going up in there 3/4 of an inch, so we'll give that a shot. All right, and we're tightened down on the flat. Yep. I don't know if that one will, no, we can't reach that one. All right, we're just going to use the one bolt just like we did on the others. So instead of using a little telescope gauge and a mic, I'm going to use this set of gauge pins. This goes from 251 to 500, or a quarter to half inch, in 1/1000th increments. So I measured the hole with some calipers, and we're about 454. All right, so here's a 454 gauge block, and what I'll do is I'll just use that to kind of check the fit. All right, our tap shank, mic in this right here, measures about 478.5. So we've got a, right there, we've got a 478 and a 479. So I'll probably just use the 479 as a gauge to bore it to, and use that to fit it. I think if we hit 480, it's not going to hurt anything because we're splitting it, and it's going to draw down on the shank there. All right, there's a 454. It's fitting it pretty good. So that gives me a size of where we're at and where we need to take it to. All right, I've already got this bar set to a 0, set to a stop point right there. So 50. Let's go ahead and we're going to try 10 thousandths and see what she does. Too much feed, slow it down. All right, so this is a 464 and it fits. And I tried the 465 and it's a little too tight to go in there. So I'm just going to say we're at 464. There's our 474 pin. All right, I think that's a good fit on that. So we got 5 thousandths. Let's try it. All right, here's our 479. And it fits it good. Let's see, I got a 480 here also. It's probably closer to that, but it's kind of tight. So maybe between it, about a half thou or so. Put that back in there. Let's put these back. And grab the tap. Where's the tap at? All right, it won't go in there where I want it because of the square. I've got to mill the slot through there. But the very first part of the shank of the tap is going in there like it should. And there's very little movement right there. So I think we're good to go. Just going to use this Noga tool here to deburr it. There's just another little closer look at it. All right, we're going to try this indicating again with a little bit different camera angle and lighting. And we're going to use our brown and sharp best test with that black dial because it usually works out the best on screen here. So I'm using the edge indicator arm again. This is the shank mount. And we're going to use this 5C collet fixture right here to hold our 5C collet to do our milling. And I've got the arm pretty much set up. This thing moves. You've got different axes here that move, and you can pivot and just kind of position it where you want it. So I got it pretty close. And the trick is, and Tom Lipton shows this a lot whenever he's doing his indicating. He's really good with this. Trying to position this test indicator in an upward position that you can see it from standing right here instead of it being vertical where you're having to walk around to the side. So it's got a pretty nice little friction feel to it. I could go down a little bit further too because it's on that taper there. Now this way doesn't matter, but whenever we're centering up, you just like to go ahead and find center so that you know you're dead in the center there. This way right here is, you know, your y-axis is the most important of what I'm trying to get trued up. So that right there looks like we're well within 1/1000ths all the way around. I believe that's about a 1/2 thousandths being in the center right there. All right, so we'll call that good, and we're going to set up a 1-inch 5C collet right here, and then we'll hold our piece and do our milling, just basically like we did with the little screws not too long ago. All right, now we can go ahead and install our piece, and I went ahead and got the collet set in here. You got to kind of fiddle around with the height of the collet inside this, screwing it in and out a little bit to get it adjusted right. But I think we're going to have plenty of hold. It feels very square and secure in here in this collet. Tighten it down with my hand, and I'm going to lock the set screw here. So it should be there. I'm a little worried about the height there that we gotta, you know, this is sticking out, but I think we'll get her. So the square of the tap here measures about 360. I was getting 359 and 360. So I'm just shooting for 360, and we can fudge it a little bit after that if we need to. Depth is going to be 5/8, 0.625 down. So what I'm going to start with, I've got this carbide end mill right here, and I believe this is one that was given to me by Bill Ashcraft over at 5 Star Machine. It is a 17/64 carbide end mill. I've got a few of these, so we're going to put one to use. So I just did my math here so I can figure out what we got. We want a 360 slot minus 265 divided by 2. That leaves us 47.5 thousandths to offset it each way. So I've got a mag back indicator right here on the ways, and I've got it set to a 0. I've got it preloaded some. I got it set to a 0 so that we'll use that since I don't have digital readout, and we'll move it each direction 47.5 thousandths. All right, guys, we're ready to cut this slot. So I already got my cool mist set up. I think we're ready to go. We'll just have to do some fine tuning here. Let's go ahead and we'll get started on this. I gave you 2 camera angles to play with there to enjoy. So here we go. Alright, so it looks like we're holding in there square. It just touched there on both sides. We'll do, let's see, we're going to be going up 625. We'll just do like 200 a pass. 1, 2. little squeaky. All right, I'm going to adjust that air there to give us a little bit more blow power with it. Just to try to blow them chips out of there too. I know I'm not giving it enough feed for the cutter, but I'm afraid to push it a little too hard. Try some auto feed here. How are we looking on camera? Looks like we're focused in pretty good. I got you on the tripod. The last time I tried it with that camera, it was actually on the mill here. Let me go get my little chip brush. All right, that was 2. Let's go another, we're gonna go another 2. Making a mess up here. I want to see if I believe it was only 20 thousandths I needed. I'm going to go ahead and go 25 on the dial, and that should put us where we need. All right, I'm going to go ahead and move it over. We said we wanted 47 and a half. Let's see what she does here. All right, that was 20 thou. I'm going to go back the other way. 20 thousandths. We'll make another cut. Finish it out. 47. Go the other way. 10, 20, 30, 45, 6, 7. All right. See how you're looking on camera there. There's a tap. Oh yeah, looks like we're good. It's a good fit too. I think that's going to work. Let me move the cutter out of the way, and I'll see if I can get you a little better shot of it right here. Yeah, it's a nice fit on that square right there. Alright, we're going to leave it like that. I think we're good to go. So, just some of the obvious, I need to do a little cleanup right here with the shop vac, take the cutter out, and then we'll do some deburring on that thing. Man, the finish on that just looks awesome. I love a new cutter, and especially a new carbide cutter. They do so well. Alright, let's see if it fits. Look at that. Like it was made for it. Nice and rigid. It's in that hole nice and snug, and fits the square nice for the driving forces there. Alright, so we got one more little thing to do, and that is to split it. So we'll set it up. And we're not going to use the hacksaw. We're actually going to use, I need to see if I can find a little slitting saw. So I'm going to have to dig around, and we'll get the vise set up and the arbor set up. And we'll come in here through one of the sides and just split it. So I'm going to set it in here on one side of the vise. I've got one parallel in there just to set it on this side here. And what I got to do is make sure that I got clearance through that inner bore so that I don't cut into the vise there. So I'm looking down it, choke up just a little bit. Now, as far as getting this level right here, there's different things you could do to make that really accurate. Level it, indicate it, whatever. I'm just going to do it where this one's going to be real simple. We're going to put that tap in there, and I'm going to look down. I'm going to look down it, and I'm just going to level it like this. So looking at it that way, it looks like it's nice and level. Actually, just a touch high. All right. There we go. That should work. So we'll install our cutter, and then we'll have to come in here and just kind of touch the top off to establish our tool depth, which is going to be 520 thousandths once we touch off. So I just realized something with that key knot in there. The forces is actually going to try to move it that way, which is going to loosen it up. I wanted to bring the cutter from back to forward this way, but I'm going to flip that cutter over and we'll go that way. That way it's in a tightening rotation instead of loosening. Don't need another one of those. Alright, so now it's in a tightening position. And we're just going to use our all 16ths here. So I'll just do this by hand. I've got the cutter sitting over the center point of the part there. I'm just listening for it to rub. There it is. I was actually a little bit past it, so you couldn't really hear it. It was rubbing, it was pushing up on the cutter. All right, resetting my Z to 0, and we're going to go up 520. 1, 2, 3, 4, 520. That should put us in the center. All right, that's the best I can do for the Sony cam right there, because I got to have room to feed the mill. So we're going to give this another shot. That ain't good. Come on now. Let's see what it's doing. It's trying to grab it. Is the tooth clogged? Might have been a little too aggressive. Those are some very fine teeth on that cutter. It might be trying to collapse on it. It was almost through with that cut. I think it's trying to collapse the onto the tool. Yeah, it's getting hot. This is not going my way, is it? All right. I think I got it that time, guys. Let me see if I can find something. All right, I finally prevailed and got the slot cut through there. It was sure giving me a tough time at it, but we got her. All right. Alright, so we just got this piece of scrap steel and I'm putting a tap size hole through it for 5/8. 17/32. Or for you metric guys, it'd be 13.5 millimeters. And I'll bring you right back and we'll try this brand new adapter that I just made to power tap it. Alright, we got the tap adapter installed on there. So what had happened whenever I was splitting this thing open, it tried to draw a little bit and close up. That's why it was binding up on the cutter. Alright, so I had to take and lightly tap it on there. So that's something to keep note of, is probably need to give it a few more thousandths clearance whenever this thing is bored and milled here on this side. And it also could be very well because of the material right there. I wouldn't have thought that it would spring closed like that. This being stress proof, I don't know if just regular old cold roll 1018 might react a little different. So anyway, we got her on there. We got our 7/8 collet in here. I'm gonna go ahead and finish snugging her up. And we'll tap a hole. And hopefully it will not make me look bad. So here we go. We're at 135 RPM. All right. Well, it worked. There's our first hole. All right, guys. All right, well, that's the end of this project right here. And now I've got a pretty decent little set of tap drivers. Although one of these, actually both of these, would need to be turned down to fit the 7/8 collet. One thing to remember or keep in mind is that I was actually making these back whenever we had our Acra mill there at my old shop, which we now have down there at work. So, you know, we have a collet down there that goes up to 1.25 inches. Now, unfortunately, I can't use this in the K&T because it does not have a floating quill. So it needs to be able to float, you know, so hold it in your, in a Bridgeport style of mill like that so that the thread can pull itself down in there. So we got it half, now 5/8, and 3/4 and 7/8 here. So one thing to remember, we need to make sure if we do this again, or if you guys decide to do that, go ahead and make the bore. Let's go ahead and make the bore a few thousandths bigger. I would have to play with another one to see how much bigger we'd need to make it, and open up that slot just a little bit. I'd say no more than 5 thousandths. That's probably pushing it, really. But it doesn't take much pressure at all. You can put this in your arbor press with this pin right here, and just a little bit of pressure, and it just pushes it right on out of there. So that's a cool little project you can do in your shop on, you know, if you're looking for something to make. And these help also to eliminate putting extra wear on your chuck jaws. You know, sometimes whenever you're power tapping, it wants to spin on the tap. So that could help out with that as well. All right, guys, that's it. We'll see you on the next project, okay?